Okay. All right. So, as I said last week or yesterday and all of the time, uh, you should let me know if you can't hear. So chat something. I have a microphone. Sometimes if it's attached, it works better. Sometimes it works worse. So I unplug it and plug it, and sometimes it fixes things. So let me know. Later today, tomorrow, I'll send out an email about the final. Because some people are in different time zones, I'm going to be asking you if you're going to be able to take the final at our usual time or at a different time for one of a few reasons. One is you're in a different time zone, one, you have a conflict, and one, you have miscellaneous reasons, I guess. So when I do that, you're going to send back alternate times that you can make, and more exactly, you're going to tell me when your other finals are. So try to find that out for the weekend. Okay, so quiz on Monday. So let's start with that. Do you want to see any examples from stuff that's on the quiz, of which there are three types? One is the power series, where we get the radius and interval of convergence. One is from 3.1, which is distance and displacement for a one-dimensional function, and 3.3, which is a displacement and total distance if we're looking at a vector. So do you want to look at any of those types? Those are all pretty easy to make up. So do you want to see one from, let me ask in order. Do you want to see a power one, which is the interval and radius convergence? So anyone want to see that? Okay. So let me go to a new one. So I'll erase this. And as usual, I'm mixing up my variables, sorry. So that's an x plus 1 to the k over k times 4 to the k in the denominator. So for all of these, which test are we using for the initial part? Yep, so lots of people got it. So ratio. And again, sorry about string remarks. Marks. So as usual, ratio is the k plus first term divided by the kth term. And as usual, for these, at least some of it cancels pretty nicely. And as usual, if you get back a part that is something like k squared or k, like here, what does that usually happens to that? So what is this limit? Okay. And then the follow-up question, which is similar answer. So 1. And what do I need that to be less than for this to converge? And 1 again, kind of the same answer. So what is the radius of convergence? Yep. Because remember, I'm going to try not to write too much because I want to try to keep everything on the same page. So The radius of convergence is 4. Remember, for the radius of convergence, we need it in the form x minus a is less than r. So if you have a number in front of the x, so if I had done 2x plus 1, you would have had to divide by 2. And what is the interval of convergence? Right, so the center is -1. And then I add and subtract 4, so I get that. Am I done? Okay, so we have to look at the edges. So now we have to look at 3 and -5. So let me plug in 1. And since I don't have as much space, as I said, I'm going to try to simplify things as I'm going. So if I put in x equals 3, I get 4 to the k in the numerator, and k and 4 to the k in the denominator. So it simplifies to that. So any questions on this? As I skip the step where you plug it in. Okay. So what happens to this one? Does it converge or diverge? So this diverges, and because why? And you have two choices. All right, either it's, you can say it's because it's a harmonic, or you can say it's a p-series with p less than or equal to 1. So that part diverges, so we don't include that endpoint. If I put in -5, again, I'm going to skip the middle step. In the numerator, we'll get -4 all to the power k. And then the denominator, we'll still have the k and 4 to the k. And I will get that. Again, let me wait a minute. See, do you have any questions on this? Okay. What type of series is that? Okay. So this is alternating. And therefore, we have to check the two things. What are the two things we have to check? The limit? Yeah, it's hard to write some of this up, so I'll keep it short. So limit as k goes to infinity of the 1 over k, that's equal to, someone already said, which is what we need. If it's anything else, we're done. And the other thing we need is that the terms are decreasing, right? So therefore, it's converging at this endpoint. So I go back and include the -5. And there's my final interval of convergence. In theory, there are the two simpler ones. If, for example, instead of this, and I'm not going to write it in, but if I made that k factorial, we would find the limit in the ratio test is 0, which means it converges for all of them. And if I put the k factorial in the numerator, I would find that the ratio limit will go to infinity, and therefore it'll only converge at the center, in this case, -1. In theory, those could come up in the quiz, but they won't, because I want to have one where you actually show all the steps like we did here. So any questions on these steps? So there will be one like this on the quiz. Okay. So second type of quiz is, question on the quiz is the 3.1 question, which is given a one-dimensional function, then get displacement or total distance. Does anyone want to do one of those? Okay, so let me erase this. And so here I can either give you the distance, start with the distance function, the position function, or the velocity function. And after I do this, with this one, I'll ask how it would work with the opposite. Okay. So here's a one-dimensional velocity function. So there are the two types of questions that could be up on it. So let's find the displacement from 0 to 3. How do I do that? And the numbers aren't going to be very nice. Right, so integral, and then put in the two endpoints. So we're just going to do or you can get the antiderivative in general and then plug in the points into the position function. And let me try these quickly. As usual, you're going to double check my numbers. I get 2.25. So on the quiz, for displacement, I'll probably actually have you do it because it's fairly easy. In this one, I probably will not make it any more complicated than this integral. In theory, there's no reason I couldn't do a substitution one or integration by parts, but I will not. Okay. If instead this was a position function, then what would I do? So I won't cross off the v and make it an x because we're going to use it for part b. Right. So if instead you start with the position function, you just plug in the numbers. So b let's find the total distance. Again, I need to integrate, but now instead of integrating the velocity, what do I integrate? So for the displacement, I integrate the velocity, get the position function, plug in numbers. For the total distance, I integrate instead the what? The magnitude or speed. So this magnitude of velocity, which is the speed. I'm not going to write it here because I'm trying to save space so I can fit it all. But here we're going to do the integral of the speed, which is the absolute value of the velocity in this case because it's one-dimensional. So to integrate the absolute value, what do I have to do? I have to find where the function is or where the velocity is. 0. So I'm going to set 0 equal to obviously I can factor out AT. And in this case, I think last class, the class before I messed up and it didn't factor. This one does factor. This factors as as that. And so therefore, as I was writing, I should remember that is the lag with the chats. Sorry about that. So therefore, it's 0 at 0, 1, and 2, which means when I do the integral, I'm going to break it up at 0, 1, and 2. Obviously, I don't care about the 0 because we're starting at 0, but I will have to break it up at 1 and 2. And if you want, like I am here, you can just write the v of t instead of writing out the full velocity. And I'm not putting in the plus or minus here for a second because remember, there are two ways I can deal with this. I can either find whether the velocity is positive or negative in front of each and then change the sign, or the more basic one is just take the absolute value sign outside of the integral, which is telling us do the integral in the usual way, take the antiderivative, plug in the two numbers, and subtract, and then at the end of it, whatever that value is, make it a positive. So if you leave the absolute value inside the integral, I might take off a little something because that's what we're starting with. As I said, I didn't have room here, but actually I sort of do here. That's what we're actually getting, the integral of the speed. And so if you leave the absolute values inside the integral, you're pretending in some sense that you missed something because you might have to break it up. This quiz I probably won't, but it's possible that if you leave the absolute values inside, I might take off. It's the second type problem. And as I said, there are the two ways I can present it. I can either give you the velocity or I can give you the position. So if I give the position, if this was instead, now I can cross it. If this was the position, what would be the initial step in part B? What would I have to do first? So there are two kind of separate questions. So the separate integrals are in some ways no longer, I guess they are no longer speed, because now once we take the and plug in the numbers, we're getting distance, and we're making it into just a total distance because we're saying we're ignoring the direction. Because remember here, we're only either going left or right. So some of these integrals are going to be positive and some are going to be negative, saying we go to the left for some time and go to the right for some time. Absolute value just says whether it's going left or right. We just want to know how far does it travel. On the other hand, absolute value inside, so this one here is saying we're looking at the integral of the speed. So absolute value of v of t inside the integral is speed. Outside of it, it's just saying make it into a positive value. So the initial step I have to do if this started with x of t, I would have to take the derivative to make it velocity and then do the same thing. Find where the velocity is 0 and so on and so on. Okay, so any questions on this step? Oh, and I should say, as it is here, this is probably how it will be on the quiz, which is for displacement, I will probably have you actually give me back the number because it's fairly straightforward and quick. For the total distance, I will probably have you just set it up like I do here. So any other questions on this? Actually, before I erase, so same thing. I'm assuming now the answer is yes, but just in case, do we want to do the same question except now for a vector? So 3.3. Yes. Okay, so let me erase. And last one, I'd start with velocity. So this time, let's make it a position function. Officially, it's a vector, but you know, it's right like that. So again, the easy question, what is the displacement from 0 to 1? So all I have to do is, someone said in the last one, plug in. And the difference between this and the last one is when we get the displacement result, we get it back as a vector. So as I said when we were still in class, just like in physics, we want it in the pieces. It's moved 1 unit in the x direction, 1 unit in the y direction, and e units in the z direction. Again, trying to save space. So part B, let's find the total distance from 0 to 1. And so as someone said in the last one, our first step is we have to get the velocity. And how do I take the derivative of a vector? I just take the derivative of each piece, so component by component. So the derivative of t squared by itself, derivative of t by itself, derivative of t times e to the t by itself. And as I said, I think yesterday, this is kind of an excuse for me to check to see if you remember your derivative rules. So for example, here, for the third term, I need to use the, which rule? Product rule. Yep. So take the derivative of t, leave the e to the t alone, leave the t alone, take the derivative of e to the t. So in terms of the setup, it looks the same, which again, we're looking at the integral of the speed. It's just that now what look like the absolute value signs are now magnitude, as I think someone said before. And we know that the magnitude comes from Pythagorean theorem. Which is the square root of the sum of the squares. And this definitely I will have you as it is, so you wouldn't actually evaluate the integral. There are ones where it works, but for the quiz, I'm not going to do one because I want to be able to ask the 3 or so questions, so don't want to make any of them individually too long. So any questions on this? So again, I can either start with the position or the velocity function. And also remember, this one has an alternate, which is called arc length. So again, I'm kind of assuming at this point that it is, but just checking. Do you see an example of arc length? So does anyone want to see arc length? Yep. All right, so erase. So the wording is a little bit different, but it turns out it's similar to the last one. Okay, so it's back already. So someone said mic was stuck. Okay. So remember, the idea is we can make this into a vector function in a fairly easy way. And I'll put this in here because you don't really need it, which is I can let x be x and y be that. So now I have a vector function, and now it looks like the last one. You assume this is the position, and therefore, like the last one, we have to get the velocity function. And we know that the derivative of x is, of course, 1. And so remember, the formula here simplifies, so you don't actually have to use the same thing as you do in the last one, but you can. It simplifies to this: the square root of 1 plus the derivative of f squared. And as I said, you can think of it as it's really the last formula if you think of this as the parameterization, because that first 1 is the derivative of the first term to make it a velocity, and then the derivative of the second term to make it velocity, and then square root of the sum of the squares. So you can either remember it as a variation of the last one or remember it as a separate formula. And now you just plug in. And as with the last one, it's kind of an excuse for me to check to see if you remember your derivatives. So here, if you remember chain rule. Also, like the last one I should have mentioned is, so here, I will just have you set up, so that would be the answer. But also remember, as I've said numerous times, unless you're going to use it in a follow-up part, once you get an answer, you do not have to simplify. So you have to do all the preliminary steps. So in this case, that means take the derivative, but you don't have to square everything here. You can just leave it like that. And so this is the other variation that could be on. So in some ways, the last problem and this problem, I think of as similar. So you'd probably just get one of those two. Okay, so any questions on this? Okay. All right, so that's what's on the quiz. And we do stuff that isn't on the quiz. Usually on the quiz day, we do the usual 10-15 minutes of new material that's not on the quiz in the quiz. Since it's the first try at quiz, Monday again, we're only going to do the quiz. So you'll come and do the quiz. When you finish it, you'll submit it, and then that'll be it. Okay. All right, so let me go on to the next thing. So any last minute questions? Sorry. Any questions about what's on the quiz in any of those types? Okay. Right, so it'll be the radius convergence, the two displacement, distance traveled, and then related the arc length. Okay. All right, so yesterday we did volume with all the different cases. So pretty much I'm just going to give you another one where we do all the different cases, of which there are, as you'll see, sort of 6, which is rotate around the axis, rotate around something parallel to the x-axis below, rotate about something that is parallel to the x-axis but above it, rotate around the y-axis, and then left and right of the y-axis. So start with a region. Sorry about the excess line. So we're going to rotate the region enclosed by y equals x squared and y equals 2x about some region. And this is in some ways a reminder that I can make you do little calculations to figure out where the region is. So for example, here, it's pretty easy, but there's our region. And you just have to get that point. So you might solve a quadratic equation. This one's simpler, but. So what is that point? Partly, right? So 2 and 4. And remember, if it's not obvious, like it sort of is here, just set the two equations equal. So in this case, you would set 2x equals x squared and solve. And that would give you the 0 and the 2. So here, I'm going to stop drawing it after this one. But remember what we're doing. Also part A about the x-axis. Partially because of my drawing ability. So make this into, connect it using the arcs, the circles. And we know when I make a cut at x, so if I make a cut at x, I'm going to get a washer. And for the washer, I need 2 radiuses. So R1 is the smaller, the radius in this case from the x-axis to that bottom curve. And that's supposed to be an R2. R2 is the length from the x-axis to the one that's further away. So what are the 2? Does that work? Anyone hear me? Yes? Okay, so as I said, I plugged in the mic, so it'll probably go out after a while. So again, just let me know. So we need R1 and R2. So R1 is shorter region, which in this case is which function? And R2 in this case is the one that's further away, which is obviously the other function. And what is our general formula? Because we're going to rotate this around getting a circle, so therefore the formula will be just the pi r squared. And remember, in the general one, there's a hole in the middle, so we're going to get the volume of what we get if we rotate just the outer region, and then subtract what if we rotate just the inner region. So we found that the points are 0 to 2, so therefore the integral from 0 to 2, and it'll be pi of the outer one minus pi times the inner one squared. Since both of them have pi, if you want, you can drop the pi. So you can either leave it like this or factor out the pi. Again, I'll probably just have you set it up. This isn't on the quiz, but when it comes to the test, we'll probably just have you set it up. So if you want, you can leave it like this, or you can make it's 4x squared next to the fourth. Right? So there's the base one. Any questions on this? As always, give me a good chance. This is vacuuming nearby, so sorry about that. Okay, so let me erase. Right, so in theory you could, because if you look at the last example, the integral is actually pretty easy, but we usually don't have you actually integrate. So what I left was what your final answer would be. What if we're rotating about something that's parallel to the x-axis? And so, whoops, not sure what I'm thinking. That should, of course, be y equals -3, parallel to the x-axis. X equals -3 would be parallel to the y-axis. So that should be a y equals -3 in both places. Sorry, because I can't erase. And again, we're going to rotate it around, get our washer, and again, we're going to need our two radiuses. So the same basic formula is there, but now we just get two different radiuses. So here, R1 is, all we've done for each of the radius is, what have we added? Right. So therefore, it's still, the closer one is the x squared, but we've added 3. 2x is still the further one away, and we've added 3. We're still doing the region from 0 to 2, so the limits don't change. And again, the basic formula is pi r squared. This one really we'd have you set up. It isn't difficult, but it's tedious. We'd have to square both of them, collect like terms, and so on. So this one, we would definitely have you leave it as it is. So any questions on this? Okay, so erase. The other variation is rotating around a line above the figure, but still parallel to the x-axis. And so now, when we rotate it, we're going to rotate it this way, and our radius will be going here. And now the curve that's closer to what we're rotating around is which function? So which function now is closer? So now it's 2x. And what is therefore R1? It's the distance from 2x to 5, which is 5 minus 2x. And R2, now the further one away, is x squared. And again, the distance from 5 to x squared is, because remember, when you're finding distance between 2 points, you just subtract the smaller from the bigger one. Again, same basic formula, pi r squared. Okay, so those are the 3 cases where we're either doing the x-axis or something parallel from either above or below. Remember what I said yesterday is, in theory, we could do something inside. So this is the point 2, 4. So in theory, we could do rotated around y equals, say, 3. But we're not going to, because that makes it a bit more complicated, and this isn't really a general application, so it's silly to make it too complicated. So we will not have something where it goes around in the middle. So any questions on this one before we now go to the y-axis? So erase. It's the same picture. D. This one I'll do on 2 slides because I'll remind you what we're doing because we have the new formula from yesterday. And I'll actually do it in the next slide. So here again is our picture. Okay, so it's lagging a lot, so it didn't show the drawing for a second. So I'm getting the bowl, which I can almost draw. And remember what we're going to do is we're going to look at it from above. So I said this one just reminding you of what we're doing. So from above, we're going to break up into little pieces like that. Pull it out. So let me look at it here. So here's our little slice. Unroll it. Make it into a rectangle. And we know the area of a rectangle, of course, is height. Height is, you can see in the picture. And as always, the perimeter of a circle is 2 pi r. And you can see that that is the perimeter of that little cylinder that I did. And as with all the ones before, we're assuming we're making the cut at x. So therefore, our radius will be x in the basic one. So our base area formula will be 2 pi x times the height which is the top function minus the bottom function. So there's, and then we integrate over the region, which in this case, again, be 0 to 2. So let me redraw it without the extra stuff. So since it's the base case around the y-axis, the radius is the x, and the height is that distance, which is the top function minus the bottom function. And that gives us this. So our base radius is r. And our height is the 2 pi x minus x squared. And the dx is the little thickness of that cylinder to make it into a volume. And then we add it up over all the possible rates. So the cylinder is cutting out of the revolved bowl, right? So in some ways, pretend you have a round cookie cutter type thing, and what we're going to do is plunge it into the little bowl, pull it out, which will give us a really thin cylinder, and then unwrap it. And then we're going to make that little cookie cutter a little bit wider so that we get a slice further out, pull it out, and then keep. Okay. So here, let me put them together. That's why I tried to do it on 2 slides here, is is let's rotate it around something to the y-axis. Let's say x equals -3. And looking at the last one, the question is which of the two things changes? So we have a radius and we have a height. So let me start with the easier one in this case. Does the height change from part D to part E? Oh, and someone asked the question I almost did, which is which one changes? And someone said, so yes. So H doesn't change. You can see if I rotate this around, it's going to have the same height as the one I had in part D. So that's still 2x minus x squared. But you can see R changes. And what is the new R? Right, so add 3. And again, there's our answer. So H didn't change, so it stayed where it was. We added 3 to the radius, so we get that. Notice for all of these, which will also be true in the next one, is our limits for the integral stayed at 0 to 2, because the region itself is from x equals 0 to 2. In theory, for both of them, we now have two ways of doing it. The first 3 parts that we've done were washer, which is where we make a cut and we get the washers. This one where we make a cut and get cylindrical shells. In theory, I can use either in terms of x or y. So I could be doing washers here, but to do it, what I have to do is solve for the equations in terms of x. So right now I have, for example, y is equal to x squared. I'd have to solve it, get x equals square root of y. And I have equals 2x, so x is equal to 1/2 y. And then I could use the pi r squared formula again. I like doing it this way, but you can do it either way, which is I pretty much exclusively will use the washer method if I'm going around the x-axis or something parallel, and this cylindrical shell if I'm doing y-axis or something parallel. So any questions on either of these before I do the third type, which, as I said, is now to the right. So we did the left, we did to the right. You can see it won't change much. So any question on either of these two parts? Okay, so let me erase. We have to E, so F. So the same question is part E. Does H change here? Is the height of the cylinder we get any different from part D or E? Nope. So again, it's the 2x minus x squared, top function minus bottom function. And now this is R. So what is R? Similar to part C. We do the bigger minus the smaller, so it's the 5 minus x. And again, our basic formula, 2 pi times R times H. Okay. So any questions on this? Oh, so here, R is the distance from x to 5. And the distance between any 2 points is always the smaller subtracted from the larger. So here 5 is bigger, so we subtract it. If you go to the last one where we went from, I forget, was it -2? but let's say -2. From -2 to x, we did x is bigger, so we did x minus -2, which is else 2. So we always subtract the smaller function from the smaller number from the larger function number. So any other questions on this? Okay, so let me do one more example, which I think came up as a question yesterday partially. And since we're getting fairly close to the end, just do the 1. Let's just do the x-axis. So we have y equals x squared and y equals x2. As I said here, I might make you do the little algebra to see when it's true. So I get the x squared minus x minus 2. So therefore, the solutions are at -1 and 2. So the question was, can I have negatives from yesterday? And here you can see we do allow the graph to go into the negatives for x, but it doesn't affect how we set up the integral, because what we just need is, and I do a generic x, I just need to, again, know what is the smaller radius at a given x. So here the lower function is the x squared. The bigger function is x plus 2. And that is true from -1 to 2. And again, we use our basic formula, pi r squared. So the fact that the limits go from negative doesn't really matter. If I tried to do something where the top and bottom function change, which I will not, then we might have to break up the integrals. But as long as top and bottom function don't change, you can just do the one integral, and it doesn't matter if it's negative or positive. This might not come up as much just because now I can't ask you to do the rotation around the y-axis, because now it's going to overlap. I could, for example, do it rotate around x equals -3, so further to the left so it doesn't overlap, and it would still work. So any questions on this? Okay, a little thing. So as I said, I'm putting these in sort of 3 places. So this is recorded, and so therefore, if you go back into the Collaborate Ultra, and you can see it under recordings, I'm also putting it on YouTube, and then also I'm writing out the notes and putting them on Blackboard. And because I'm writing up those before, for example, today, on my notes online, there's going to be one further example, and with a couple more parts for each of these. So a bit more than what we did today. So you can revolve this around the y-axis. What just happens is that as you revolve it, you're getting the same place more than once, so you're getting overlap, which means we'd have to break up the integral, and we don't do that. So yes, you certainly can. It's just that it makes it slightly more complicated, and we don't want that. So it would be easy to rotate around, say, x equals 5, because that then is outside this area. So when I rotate, there isn't any overlap. But for y-axis, we don't want. So second test is not next week. I think that's what's on the schedule. But it probably will be in 2 weeks. As I said, so what I'm going to do today, tomorrow, is I'm going to send out an email asking a few things. One is the main thing, because we're starting to set up for the final, is will you be in a different time zone for the final and therefore need to take it at a different time? And if so, when are all your other finals? I'm doing it. I'm also asked about the test. So the test could be 2 weeks from today. And so I'll ask when you have the other tests, and also if you will be in a different time zone, so need to take it somewhere else at a different time. So that I'll ask in an email. Also, it partially depends on what happens on Monday, because if it goes well Monday, then the test will definitely be in around 2 weeks, give or take a class. If things go poorly, I'll have to figure out what might work. So still a bit up in the air, but for now, tentatively, the test is in 2 weeks. So any other questions? Okay, so let me stop the recording. If you don't have any questions, we're done. If you do have questions, stick around. I'll stick around until the end of class and just go over